empty. Okay, so this was 2006, the C part. Can you make a deciliter measurement from a metal sheet with these dimensions? We've defined volume, radius and height. We know the formula, volume is pi r squared. We know that we have to make a measure of 1 deciliter. The first thing we have to think of is how much is a deciliter in centimeters cubed. What do we know about the measurement litre? Well, we know that a litre is the same as 10 deciliters, but we also know that 1 litre is the same as 1 decimeter cubed, and 1 decimeter cubed is the same as 1,000 centimeters cubed. So 1 litre is 10 deciliters and 1,000 centimeter cubed. So if we would like 1 deciliter instead of 10 deciliters, we would divide that by 10. That would give us what 1 deciliter is. So we would do the same here. Divide centimeters cubed by 10. So 1 deciliter is the same as 100 centimeters cubed. So that's the first thing we have to define. We know that we have to measure 1 deciliter, which is the same as 100 centimeters cubed. So now we know which volume our deciliter measurement has to have in centimeters cubed. That's the first step. We also know that we have a maximum height of 6 centimeters. So if we just to plug in what we do know, the volume is 100 centimeters cubed equals pi. We know that pi is 3.14. We don't know what the radius is yet, but we do know that the height is 6 centimeters. So the quickest way to just do a quick calculation of whether we have enough sheeting to make a deciliter measurement, find out what the minimum radius we could use is. We then get that r squared is 100 divided by 3.14 times height. Calculator, please. What have I done here? Well, I want to get r squared by itself, so I've moved both of these two over to the other side by dividing by them. Divide both sides by 3.14 times 6. If I do that, divide this side by 3.14 and 6, the 3.14 and the 6 cancel, giving me 100 over 3.146 on the other side. Giving me 5.3. So we know that the radius squared is 5.3. How many, a bit more decimals than that, please? 0.07 centimeters squared. Don't round. 0.
8
if you round it off. So to 3 decimals. Keep a few decimals in there. I'd recommend keeping to 3 decimal places or 4 significant figures in the beginning. Right, now we want to know what r is. So r is going to be the square root of that. 5.308. You can keep the whole number in here. And that's going to equal 2.304 centimeters. Okay, that's going to be exact. What I'd probably do here is say, right, if I can keep a radius then of 2.4 centimeters, I know it's going to be slightly bigger than 1 deciliter. If I do 2.3, it's actually going to end up being slightly smaller than 1 deciliter. So I'll keep my radius of 2.4 centimeters to make sure my deciliter measurement is slightly more than 1 decimeter. Because I know I can't go over 6 centimeters, so I can't increase that one. It's slightly larger than 1 deciliter. Right. Now I know what my radius is, I need to know if I've got enough length to be able to manufacture the bit that goes around the deciliter measurement. So now I have to do that the circumference around the base of my metal plate is going to be 2 times pi times r. So we're going to get 2 times 3.14 times the radius 2.4, which is going to be 15 centimeters. So that would mean I'd have first 15 centimeters here of my 24, use the whole height, so I would 6 centimeters by 15 centimeters, and then I would have a radius of 2.4 on my circle. So the length of plate that I'm going to need then, the length of the metal sheet, is going to be 2 pi r, which I already know, plus 2 times the radius for my circular part. So I'm going to have 15 centimeters plus approximately 5 centimeters. So I'm going to need 20 centimeters length, and I've got 24. So yes, I can absolutely make this measurement. And I'm going to have quite a lot of space left over. So this is, if you've used this method, taking the square, calculating r squared, and then taking the square root, and finding out, yes, I can easily make a deciliter measurement, you've ensured all of your A points. There's another way of doing it where you say, okay, let's take a maximum radius, and this way is a little bit more complicated. Let's say that I use the whole of the radius for one circle. So I actually make a big circle here where I say that assume the radius is 3 centimeters. And then I say that the volume is the volume divided by pi r squared gives me what the height is. So what height would I need to have a deciliter measurement? So if we do this one, we get 100 divided by 3.14 times 3 squared, which equals... Are you with me what I've done here? I've just reorganized that. Taken pi and r squared, divided both by pi r squared. That cancels, giving me that h is v divided by pi r squared. What do you get then? 3.54 centimeters. Okay, so we now know that the height is going to be 3.54 centimeters. We don't need very much of the height. But is that going to be enough then? Are we going to have enough sheet if we go that way? So what we need to work out now is the circumference that we're going to need for this. We're going to need that the circumference is pi times d, 3.14 times 2 times the radius, which is 3.14 times 6 equals 18.84. If we have 18.84 here, and then we need to make a circle that is 6 centimeters onto here, then this piece of sheeting would have to be 24.84 centimeters. So it wouldn't be enough, because we've only got 24. So then we'd have to actually say, okay, 3 centimeters is too wide to have the piece of the base of the deciliter measurement. And I'm hardly using any of this height, so I'd get a lot of metal sheeting left over. So what could I use instead? Well, I could do it with 2.8. Let's say that the radius equals 2.8 centimeters. So this way doesn't work, and then I've got to do a guesstimate. Let's take a radius of 2.8. We get that the height is the volume divided by 3.14 times 2.8 squared. What height do we get then? So this was first guess. Assume. And this is second guess. What do we get then? 4. centimeters. Okay. If we have a height of 4 centimeters and we get a radius, we work out the circumference. The circumference ends up being 2 pi r, 2 times 3.14 times 2.8, which equals 17.58 centimeters. Okay, so now we've got about 17.6 centimeters. If we have that the length for the circumference around the deciliter measurement is now 17.6, and we add 6, well, it won't quite be 6, will it? It'll only be 5.6 centimeters to that. So then we'll get 23.2. So this new distance, 17.6 and 5.6, will now be 23.2 centimeters, which is enough. So this deciliter measurement we could make. So what do we do to make sure that we've done everything right? Well, we would take our we would explain our working out, which of course is going to take a while with this one. We'd have to show that when r equals 2.8 centimeters, the minimum height necessary would be 4 centimeters. The volume then equals 3.14 times 2.8 squared times 4. What volume would we get then? So this is our check. 98.5. So we'd probably increase that to 4.5. We've got enough, or 4 point. Yeah, we can increase it a half, no problems here. 110 centimeters cubed. So we could do it quite easy, but it's going to take a while to explain this in words, what we're actually doing. And you'd end up with probably too large an assumption of the radius in the beginning, so this way takes more working out and gives you less points than the first way. So choosing the correct method and saving time actually gives you more A points. Get it?